Here's a term that you'll hear too in upper math. It's called inscribed. That's when you're putting a shape within a shape. Here I have a square. The circle would be inscribed if it fits right in that square. Do you see how the circumference of this circle is touching the sides of the square? This would be called a circle inscribed within a square. You could have a triangle inscribed within a circle. Maybe we'd have this. But some of the points of the triangle would have to reach out and touch the circumference of that circle. So one shape is inside of another. That's called inscribed. Scribed means write, in, within. So we have a circle that's written inside of this square, and we have a triangle that is written inside of this circle, inscribed. When you have an inscribed situation, like this one, knowing that we have a diameter, the diameter of this circle goes from one edge to the other through the center. Okay, through that center point. And it's the diameter of that circle is the same as the length of the side of the square. So if we knew that this square was 3 by 3, we would know that the diameter would also be 3. So when we go to use our formulas for area of a circle or area of a square, we could figure out how much of this square was taken up by the circle. We first of all would find the area of the square. Area of a square is equal to length times width, or sides, side times side. So in this case we would have side squared. So area would be equal to 3 squared. Area is equal to 9. So we have the square being 9 units. Now the circle, to find the area of the circle, we would have to use the formula area is equal to pi r squared. And pi is this figure right here. We can use the decimal or the fraction, the 22/7. Pi actually is an irrational number, goes on and on forever, but for the reason of working problems, mathematicians usually cut it off at 3.14 if you're going to use a decimal, or 22/7. So in this case, if we did the area, I'll use the decimal, equals 3.14 times the radius, which is half of this. Radius is half of the diameter. So I would have to use 1.5 squared. So let's take a look at how that might look. Let me give myself some room. So this is where figuring the area of the circle is pi r squared. Area is equal to 3.14 times the radius. We have a diameter figure here, so we'd have to cut that in half. So it would be 1.5 squared. Area is equal to, I'm going to do this portion first because exponents come before anything else in the order of operations. This parenthesis tells me that I have it's just a single number, so I can square it. So I'm going to come over here and I'm going to square it. 25, carry 2, I have 7, and 5 and 1. 12 and 2, and I have 2 decimal points, so it's here. So now I have 3.14 times 2.25. Another calculation has to be made. So now I'm going to go 3.14 times 2.25. And I'm going to get 20, carry 2, that's a 7, and 15. Then I'm going to go 8, 2, and 6, 8, 2, and 6, 15. Here's a 10 combination, 15, 16, 6, 7, 8, 9, and 10, and carry 1 and 7. 4 places over, 1, 2, 3, 4, 1, 2, 3, and 4. Area is equal to 7.0650, and I can round that to the nearest 100 perhaps. We're going to go area is equal to 7.07 because this has power with our estimating. It has power to bump that up. So this is units squared. So that's my circle, and here's my square, the 9. So now my calculation is to subtract 9 for the square, that's the square, and I'm going to subtract off 7.07, that was the circle. Let me move that over a bit. Okay, let me put some, now I'm going to borrow here. 10 take away 7 is 3, 9, and 1. So the area of the square that's showing is 1.93 units squared. And that is all that we have area for the square, because the circle, which was inscribed within the square, takes up most of the room.